Okay, so we're going to talk about probability in section 8.7. So here's an introduction of kind of what we're talking about. So there's this chart, and it's the hours of sleep Americans get on a typical night. Okay, so maybe you get 4 or less hours of sleep, maybe you get 8 hours of sleep, maybe you get 10 or more hours of sleep. And then this is the number of Americans in millions that get that much sleep for a total of 300 million. Okay, so that's kind of important. So let's say you're getting 6 hours of sleep. 6 hours of sleep. Well, it says 75 million out of the 300 million are getting that amount of sleep. So then we can represent that as a fraction. You could reduce the fraction, it's 1/4. But you can change that to a decimal, 0.25, or you can put it as a percent. So you could say, well, 25% of the Americans that we had in our thing, the 300 million that we surveyed or whatever, they're getting 6 hours of sleep. Okay? So that's what we're talking about with probability. We're going to have probability either as a decimal or as a percent. You'll see it both ways. If you're really talking about probability, it's usually written as a decimal, though, to be honest. Like if you're looking at an empirical research article. Okay, so it's based on an event, and they usually use a capital E for event. Something happens. Okay, so people are getting so many hours of sleep a night. Okay, that's the event. Now, if the event is certain, for sure going to happen, like the sun coming up in the morning, that's going to be 100%. We're 100% certain that that's going to happen every morning. Now, that's it as a percent. As a decimal number, it would be a 1. Now, if there's no way it's going to happen, um, I'm never going to win the lottery because I never buy a lottery ticket. Okay, so there's no way I'm going to win the lottery. That would be a 0% or 0. Okay? All right. And like I said, they're going to be written either as a percent or a decimal. You will see it both ways though. Okay. So now we're going to talk about what's called empirical probability. Empirical probability is based on observations. So it's different than theoretical probability. We're going to talk about that too, but this is based on actual data. Okay, so we went and we experimented, or we did a survey, or we got some data, and it's based on that. Okay, so the probability, so P for probability, of an event occurring is an empirical event. It's going to be the number of observations of the event happening, of E happening, divided by the total number of observations. Okay, so in our example, we had 75 people getting 6 hours of sleep, or 75 million, out of the total observations, which was 300 million. Okay, so that's how that probability was found. Okay, so they give us a chart here. They're talking about, it says when women turn 40, their gynecologists typically remind them that it's time to undergo mammography screening for breast cancer. The data in the table are based on 100,000 US women ages 40 to 49 who participated in mammography screening. Okay, so a little bit about this chart. So you take the test, you get the mammogram, person gets a mammogram, and maybe it's positive, meaning the test says you have breast cancer. If it's negative, then the test says you didn't have breast cancer. But maybe you actually did have breast cancer or you didn't have breast cancer. So if it's positive and you don't have breast cancer, that's expected. Okay, so that would be the expected results. You took the test, it was positive, no breast cancer. Okay, and you actually didn't have breast cancer. Okay. If you got a positive, and then you did have breast cancer, that would be unlikely. Okay, so because the tests are, fairly accurate. This is okay. You took the test and it was positive, so you didn't think you had breast cancer, but then it turned out you really did. So it's called a false reading. Okay, so like it's not 100% accurate all the time. Okay, and then the same thing down here. It says you do not have breast cancer, and you actually don't have breast cancer. So the test says you don't, and you don't have breast cancer. Then that is this box here. And then it said it said a person didn't have breast cancer, but they actually did have breast cancer. Then that would be that box. Okay, so hopefully I explained the boxes okay. Okay, now I want to erase my lines here because they're going to get in the way. Okay. So sometimes there are false readings is what we're trying to point out there. Okay. So it says find the probability of a woman ages 40 to 49 having breast cancer. Okay. So how many of the women that were screened, how many actually had breast cancer? Well, that's right there. Okay. So 720. So this is part A. It's 720 plus the 80 divided by 100,000 because that was the total number that were being observed. Okay, and that's going to be 800 divided by 100,000, which, okay, so if you're dividing by 100,000, you're going to move the decimal 5 places. So 1, 2, 3, I'm going to need some zeros. Okay, and so you get that. Okay, so 0.008, that's the probability that the woman in this screening, in this results, had breast cancer. Okay? If you wrote it as a percent, by the way, that would be 0.8%. Okay, now let's go to B. Find the probability of a woman without breast cancer. Okay, so that's this column here, the ones that do not have breast cancer, but they had a positive mammogram. Okay, a positive mammogram, and they didn't have breast cancer. That's 6944. And then we're dividing that by the total, probably women without breast cancer. Okay, yeah. So I need to go 92,256 plus the 6944. Okay, so when you're doing this on a calculator, you'd want to put parentheses around this. This is they're fairly big numbers. Anyway, we're getting the decimal 0.07, and that's the probability. Now remember, the probability as it gets closer to 0, it's less likely to occur. As it's getting closer to 1, then it's more likely to occur. Okay, and then our last part C, among women with positive mammograms, okay, so women with positive mammograms, find the probability of not having breast cancer. Okay, so 694 divided by, okay, these are the ones that had the positive mammogram, 720 plus 6944. Okay, let me put this in my calculator. Okay, so when I put this in my calculator, I get this long decimal. We usually are going to go 3 decimal places. That's pretty common. 0.906, it doesn't round up. So, and this is rounded off though. The other 2 weren't rounded off. Those were exact answers, but this one's an approximation. So 0.906. Okay. Now, your textbook talks a little bit about they've changed, the American Cancer Society changed the recommendations for when women are to get screenings. I think they maybe wait to age 45 now or something. So you might want to read that just so you have that information.